Hello and welcome to Math Matters. I'm Miss Granados, and today we are going to consider ways we can solve word problems. You will need some paper and something to write with for today's lesson. I'll give you about 30 seconds to gather those materials and come back. Let's start with a number sense routine. Take a look at this picture. How many are there? Can you see it a different way? What equation or equations would match the way you thought about it? Maybe you saw the eggs in columns of 3, like this, and then counted by 3. 3, 6, 9, 12, 15, 18, 21, 24. Or maybe you saw 3 rows of 8 and knew that 8 plus 8 plus 8 was 24, or 3 groups of 8 was 24. Other ways you may have seen this array is as 2 groups of 12, or 12 plus 12 equals 24. Or maybe you saw 4 groups of 6, which is also 24. These are just a few ways you could have seen this array. Keep looking for more examples of arrays around your home. Let's move on to our problem. What do you know about ladybugs? Share something you know about ladybugs. I know that ladybugs are insects and they like to eat tiny insects. Gardeners like ladybugs because they eat pests that might harm plants. Also, ladybugs are believed to bring good luck and good fortune, so a lot of people enjoy finding ladybugs. How many legs do ladybugs have? That's right, they're an insect, so they have 6 legs. How many legs would 2 ladybugs have? Yep, 2 ladybugs would have 12 legs, because if each ladybug has 6 legs, then 2 ladybugs would be 6 plus 6, or 2 groups of 6. 2 times 6, which is 12. Let's read our problem. Sam got a ladybug farm for his birthday. A ladybug farm is a kit that you can buy to raise your own ladybugs. The kit comes with some ladybug larvae that will eat and grow and eventually change into adult ladybugs. It's a great way to observe the life cycle of a ladybug. After a few days, Sam counted blank ladybugs in his farm. So we know that Sam counted how many ladybugs were in his farm. How many ladybug legs were in Sam's farm? Well, what information do we want to find out? We want to know how many legs are on all the ladybugs in his farm. Wait, how many legs are on one ladybug again? That's right, because they're insects, each ladybug has 6 legs. So I'll read it again, this time with the numbers in the problem. Sam got a ladybug farm for his birthday. He counted 7 ladybugs in his farm. How many ladybug legs were in Sam's farm? Do you know how many groups there are in this problem? Yes, there's 7 ladybugs, so there's 7 groups. Do you know how many are in each group? Correct. We're talking about legs on each of the ladybugs, so there are 6 in each group, or 6 legs on each ladybug. So what are you solving for in this problem? You're looking for how many total legs are on all 7 ladybugs. Go ahead and take about 3 minutes to work this problem out on your paper. If you finish before that time is up, solve it another way. If you finish showing 2 strategies, try solving the problem with 8 or 9 ladybugs. Okay, hopefully you're all done showing your thinking. Right now we're going to look at 2 students' strategies. First, we'll look at how Stephanie solved this problem. Stephanie first drew 7 circles. What do you think her circles represent? Yeah, the 7 ladybugs. Then she put a 6 inside each circle. What do the 6s represent? That's right, the ladybug legs. Each ladybug has 6 legs. Then Stephanie used repeated addition to add up all the legs. 6 plus 6 equals 12. Then she added 6 to 12 and got 18. She added 6 to 18 and got 24. Then added 6 to 24 to get 30. Then 30 plus 6 more is 36. And finally, 36 plus 6 is 42. So Stephanie figured out that 7 ladybugs have 42 legs. The equation she wrote to match her thinking is 7 times 6 equals 42. Adrian did something different. Adrian knows his 5's facts. He knows that 5 times 6 equals 30. He also knows that 2 times 6 equals 12. Then he wrote that 7 times 6 equals 42. So 7 ladybugs have 42 legs. He was able to figure out that 7 times 6 equals 42 because he added 5 groups of 6 to 2 groups of 6 to get 7 groups of 6. 5 plus 2 equals 7. Then he added the products 30 plus 12 to get 42. We'll take a closer look at this strategy next. Let's look at Stephanie's and Adrian's strategies. What's the same in both of their strategies, and what's different? I noticed that they both used the number 6 in their strategies. Stephanie added 6 repeatedly, and Adrian multiplied by 6. They both arrived at the same total of 42 legs. Let's look at Adrian's strategy again. Where can you find 5 times 6 equals 30 in Stephanie's strategy? Yeah, 5 circles, or 5 ladybugs, with 6 legs on each ladybug equals 30 legs. What about the 2 times 6 equals 12? Where can you find that in Stephanie's strategy? Yeah, the 2 circles, or the 2 ladybugs with 6 legs on each, makes 12 legs. So then the 7 in 7 times 6 are the 5 ladybugs and the 2 ladybugs together to make the 7 ladybugs. We can add the number of legs in each of those groups, 30 plus 12, to get the total for 7 ladybugs, 42 legs. Adrian broke up the 7 ladybugs into a group of 5 ladybugs and a group of 2 ladybugs, and then added the products together. We can see his strategy clearly in Stephanie's drawing. So let's take a moment to reflect on today's learning. What's something you feel good about with multiplication? What's something you're still wondering about? Take some time now to share out or write down your thoughts to those 2 questions. So today we solved a multiplication word problem and looked at 2 different strategies. Try this new problem on your own. On a walk, Allison caught 8 ladybugs. Peter caught 9 ladybugs. How many legs is that in all? See if you can use one of the strategies we shared today or a new strategy. For Math Matters, I'm Miss Granados, and I hope you have a mathematical day. Keep on counting.